So here to represent the pro side of the argument is GoogleNet, which is a neural net that utilizes deep learning to effectively classify images, the same kind of thing that Neil was talking about. It's a good example of complexity and sort of inscrutability in a neural network because it utilizes millions of parameters. Each of these boxes represents an entire matrix of parameters. So it's impossible for any human to go in and look at a specific parameter and be like, oh yes, that's 0.25 because it has this effect on the prediction. Like, we really don't know what's going on inside of this. It's kind of a black box. So why do we consider this acceptable? Because it works. So this is a graph with time going from right to left for some reason of results in the ImageNet classification competition, and you can see it starts near about a third error, and then it has this sharp decrease when deep neural networks are first introduced, and they get more and more complicated as computation power and understanding increases until you reach GoogleNet on the far left. And there it's about only 5% classification error. So the reason that we can go ahead with something like this is medicine already does. So think about lots of drugs, shown here aripiprazole, but lots of other drugs as well. We don't necessarily know the mechanism of action. We don't know what sites they're binding to and how exactly they accomplish the things they accomplish. They're used because we've seen them in clinical trials and we know that they decrease symptoms. And that's enough for medicine, and if it's enough for medicine, it can be enough for neural nets as well.